Welcome, class, to the lecture video on section 6.11, Hypothesis Test, Equality of Variances. So we can test to see if our sigma x equals sigma y by testing the null hypothesis of H naught, where our variance of x equals our variance of y. So if we look at an example, continuing to use our example from section 6.7, the teaching methods example, let us use alpha equal to 0.05. So our null hypothesis is going to assume that our two variances are equivalent. Our alternative hypothesis is going to assume that they have a difference. In this class, we are going to always assume that it is a not equal to. So no greater than, no less than. Again, applying our significance level of alpha equals to 0.05, we can calculate our test statistic. We are going to let f equal our bigger variance divided by our smaller variance, which will be equivalent to 6.344 squared divided by 4.853 squared, which will give us a critical value, a f test statistic of 1.709. Now we can calculate our critical value. Now this is going to have us use the new table for our F distribution. It says we can find this on table A8 in our textbooks, which for me starts on page 818. But again, that's only if you're using the same version that I'm using. So to use our F table, we have to use our 2 degrees of freedom. So for our degrees of freedom for our numerator, which in this case, since our numerator was from the sample y, that will be ny minus 1, or 12 minus 1, which equals 11. Next, we will have our degrees of freedom for our denominator. Our denominator was sample x, so nx minus 1, or 8 minus 1, which will equal 7. And as we are using alpha equals to 0.05, we will need to use table A8 to find that critical value. So our F critical value we know is, I was confused. I was thinking about the F statistic that we found. So we're going to have a critical value of 3.06. So where that is coming from is, I can get myself to the right page. So degrees of freedom for our numerator is 11. And our degrees of freedom for our denominator is 7. And so we don't have 3.60 exactly. So using our F table, our degrees of freedom for the numerator, that is going to be along the y-axis. And our degrees of freedom for our x sample is actually going to be on the x-axis. So if you're looking at the table using alpha equal to 0.05, you'll see that they only have degrees of freedom for our y-axis for 10 and 12. 10 is given to be 3.64, and for 12 it's 3.57. And so we need to find the middle ground, which is 3.60. Now that we've done that, we can make our decision. So we are going to reject our null hypothesis if f is greater than our f critical value. So By comparing our F critical value of 1.709 and 3.60, we can clearly see that our test statistic is not greater than our critical value. So this means we will not reject our null hypothesis. This brings us to step 7, where we can make our conclusion. So the data indicates that there is no significant difference between the variances, and hence their standard deviations, of the two populations of students at our 5% significance level. Don't forget, we do have our assumption that our data from each population are normally distributed. Okay, so that takes us to the end of the lecture video on section 6.11. Do not forget to do your homework.